I'm Anil Kumar, and in this video we will understand how to find the integral using antiderivatives. So this is one of the first videos on the topic. So if you are just beginning to understand how to find integrals, that is a good starting point. So what I have done in my videos is I have written a formula which is right from the table of indefinite integrals, which actually is derived from antiderivatives, right? So here is a formula which is to be applied to find integrals of the given functions. Now when we are working with indefinite integrals, we don't have limits lower and upper, like kind of like this, and the result is always a function, right? It's always a function. Keep that in mind. So the two questions here are, you need to integrate x cubed minus 5x squared plus x minus 2 d of x, and the other one is x times x squared minus 3x plus 2 dx. Now this will remind you of power rule. So when we did differentiation, so d dx of x to the power of n was n times x to the power of n minus 1, correct? Now integration, as you know, is antiderivative. If you do integration differentiation, you get the function back, right? So it's kind of the reverse thing. So integration of x to the power of n dx is x to the power of n plus 1, right? So instead of taking away, you add exponents. Instead of multiplying, you divide. So most of the formulas which we'll be working with in these set of videos will be antiderivatives, right? So antiderivatives, and we call them direct integration. Okay. So let's see how to apply the formula and find the answer of these questions. Now we'll also apply the properties of integrals along with these formulas. Properties are similar to the ones which you learned for derivatives. That is, sum and difference of integrals is sum and difference, and if there is a constant, you can always multiply by the constant, correct? So to begin with, we have to integrate this function x cubed minus 5x squared plus x minus 2 dx. You could write this as integration of x cubed dx minus 5x squared dx plus integral x dx minus integral 2 dx, right? But normally we will not be writing it. But this is just to show you the properties of integration, right? Now, so x to the power of 3, n is 3 for you, so you'll get x to the power of 3 plus 1, 4, divided by n plus 1, which is 4. So that is what it is. Now in this case, a constant is being multiplied to the function, so the integral of this will be constant times the integral of the inside function, which in this case will be x cubed over 3, right? Direct application of the formula. In this case, it is x. That means the power is 1, right? So it gets 1 plus 1 as 2. So we get x squared over 2. And here it's a constant 2. Think about 2 times x to the power of 0, right? So you get 2 times x, 0 plus 1, divide by 1. So that is your solution. You can always, if possible, simplify, but that's the most simplified form, and that's the result. So that is how you integrate the functions. So this is kind of a polynomial, right? Now we have another one here to practice. You need to integrate x times x squared minus 3x plus 2 dx. So what you can do is, there is no product or quotient rule in integration. But what we can do is, we can just expand them. So if you expand, you get x cubed minus 3x squared plus 2x, right? So the whole thing d of x. That is what you get. Apply the formula, write down the result. So x to the power of 4 over 4 minus 3x cubed over 3 plus 2x squared, 1 plus 1 over 2, and then simplify it. So we get x to the power of 4 plus over 4 minus x cubed plus x square. Now one more thing is, whenever you have these formulas, I forgot to write c, you should not be writing c for all, right? At the end, you have to add your constant c. So at the end, we'll add the constant c. The idea is that if I have a function here, let me give you an example to make it very clear. For example, I have a function x cubed and I have a function x cubed plus 2. Now what is their derivatives? The derivative of x cubed is, we want to find d dx, okay? We want to find d dx for both. You will see it is 3x squared, right? And for this also it is 3x squared. Perfect. Now as you know, if you go back, we have to get the same result, right? So 3x squared, we don't know whether the starting point was x cubed plus 2 or x cubed plus nothing. So to be on safe side, whenever we integrate, we put this. So whenever we have definite integrals where the boundary conditions or initial conditions are given, we can always find the value of c, right? So that is the reason why we'll be always adding c, right? So this c is always to be added for indefinite integrals. So what you learn here is that the result of integration for indefinite integrals will be a function. There will always be a constant term added to it, and you can directly apply the formula as it is. If you do the reverse, you should get the derivative, right? So here, if I do the derivative of this, you should get the function back. That is a good check. So derivative of this is 4x cubed. 4 cancel, you get x cubed. Do you see that? So that is a good check to do. So what you can do at this stage is check your result. I hope that helps. Thank you and all the best.